Unit 7, Target 6. I can find the partial distance between 2 points. Before we get into the examples, I want to go over this big idea. Anytime this unit that we found the distance between 2 points, we've done that by first finding the horizontal distance and then the vertical distance between them. And then we use those numbers to find the actual total distance. So if we were using a graph, we would have looked at this triangle on the graph and counted the number of boxes and said that the bottom of this triangle has a horizontal distance of 5. Then we would have said the vertical distance is 3, and then we would have used the Pythagorean theorem to come up with C by saying 5 squared plus 3 squared is equal to C squared. And so in order to find that distance, we had to first find the horizontal distance and then the vertical distance. We did the same thing with the distance formula. We first found the horizontal distance. So if we were using points on the graph, on this one I may have said if I look at the points, looks like 3, 7 and 8, 4. If I would have done x minus x, I would have said 8 minus 3 squared. And then for the vertical distance, I would have done y minus y squared. So that would have been 7 minus 4 squared, or I think in this case 4 minus 7, if I go the same direction. And so every time we found distance, we first found a horizontal distance and a vertical distance. For target 6, we're going to be finding a point that's part of the way between 2 points, or it's a partial distance away. And here's an example. What if we wanted to find a distance that's 3/4 of the way from point A to point B? That point is already labeled on the graph, it's point P. That point is exactly 3/4 of the way from point A to point B. The first thing that we see is already done is we've already found the horizontal distance and the vertical distance. I'm going to change these colors to match what we did on the previous slide. Also make the lines a little bit thinner, easier to work with. And so far they've already found the horizontal distance 8 and the vertical distance 4. And we're going to take that and we're going to work with this ratio of 3/4. So if we start with the horizontal distance, 3/4 of 8 is equal to 6. So I took the 3/4 number, multiplied it by the horizontal distance of 8, and that gave me a distance of 6. What that means that if I want to find this point that's 3/4 of the way, instead of going all the way over 8, I can go 3/4 of that, or 6. So if I start at 0 and go over 6, that's going to stop right there at 6. Another way to get that is to take the 6, since this is an x value, this is happening to the x, and add it to the x value. So 0 plus 6 is 6. Or I can go over here to this a, and I can say for point A, I'm going to take this 0 and add 6. And so my new point is going to be at 6, something. For the vertical distance, I had a vertical distance of 4, and I want to take 3/4 times this 4. So 3/4 times 4 is equal to 3. Okay, 3/4 is the ratio. 4 was the vertical distance. 3/4 of 4 is equal to 3. And so instead of going up 4 to get my point, I'm going to go up 3. So if I do that on the graph, it takes me exactly to P. Or I could say if I take the y value of 0, going back over here again to this A, take the y value of 3 and add it to the 0, I get 6, 3. So we'll do a couple more examples of what that looks like. But again, to the big idea, we first want to find the horizontal distance and the vertical distance. So if we find the horizontal distance and the vertical distance, we're going to use that with our ratio. In this case, it was 3/4. Use that with our ratio to find the partial distance we're going to go. The partial distance is represented with this 6 and this 3. So instead of going to the right 8 and up 4, we're going to go right 6 and up 3. Here's another example. Find the point which is 2/5 of the way between the points A and B. From A to B. So point A is at 310, and point B is at -7.5. And I can draw the line segment between them if I want. I want to find a point that is 2/5 of the way from A to B. So I'm going from A to B, that's why I drew that arrow. Not sure how far that's going to go, but that's what I'm going to look at. And in order to go from A to B, I have to go down so many. I can count that on the graph and see that I went down 5 units, or -5, since I'm going down. And I'm going left by 10 units, so -10, because I'm going left. If I look at those horizontal and vertical components, and I use those parts with this 2/5, I can find the partial distance. So instead of going all the way to B, I can go 2/5 of the way to B by taking 2/5 times -5. 2/5 times -5 is -2. I can also take -10 times 2/5. 2/5 times -10 is -4. So if I want to go 2/5 of the way, instead of going down 5 and left 10, I'm going to go down 2 and left 4. And that puts me at the point -1, 8. And so that's how you would do it on the graph. You find your vertical and your horizontal distance. You multiply those lengths by the ratio 2/5. And then you use those new numbers to count from A to get to your point. It's important that you go from A. The other way to use those numbers, the -2 and the -4, is to realize that the -2 goes with the Y value. So if I look at this A value that I started with, 3, 10, if I subtract 2 from the Y, and I subtract 4 from the X, my new point will be 3 minus 4, which is -1, and 10 minus 2, which is 8, which is the same thing we got on the graph. One more example, this time without a graph. Okay, find the point which is 2/3 of the way between the points A and B. Just wanted to show you again how to do this without a graph, because if you do have decimals to work with, it's going to be difficult to do with a graph. From the distance formula, we know that a total distance is equal to x2 minus x1 squared plus y2 minus y1 squared. And so if I'm looking at the partial distance, I'm going to start with this. I don't need to do the square root and the squared because we're not finding the distance, we're finding where the point is. So I'm going to focus on x2 minus x1. Normally it doesn't matter which one is x2 and which one's x1, but for these problems we want A to be the first point and B to be the second point. So to find my x's, distance, I'm going to do 3 minus -3. 3 minus -3 is equal to 6. To find my y value, I'm going to do 4 minus 2. 4 minus 2 is equal to 2. And then I'm going to take my 2/3 ratio. So 2/3 times 6 is equal to 4. And 2/3 times 2 is equal to 4/3. 4/3 is the same as 1 1/3. And then since I don't have a graph, I'm not counting on a graph, I'm going to have to go back to my point A, which is -3, 2. And I'm going to translate that using these new numbers, just like we did with the translation vector. So I'm going to add 4 to the -3, because that's my x's distance, that's my partial distance. And I'm going to add 1 1/3 to the y. And so my new point is going to be at -3 plus 4, which is 1, and 2 plus 1 1/3, which is 3 1/3.